Hey, I'm Jake. In this final video of the Making a Website series, I'm going to show you how to actually host your website on a DigitalOcean Droplet, which will mean that we can actually have the server running so that other people can access it and it's just alive in the world. I will note that I recorded this whole video only to find out during editing that none of the audio was recorded. So I'm kind of just going to do a voiceover over the first version of it because it already is there. So let's do it. So here we are within DigitalOcean though. DigitalOcean is a fantastic place to host little servers or big servers. I've used them for like over 10 years. So I would say they're highly trusted. They're not going anywhere as far as I know. So I would definitely trust them to host my own servers. So we're going to go ahead and click create and then droplets. All right. So when we create a droplet, we can figure out where we want to put it. And then we can also choose an image. An image is basically what type of operating system do we want to be hosted on our server. In this case, we're picking Ubuntu 24.04 LTS, which stands for long-term service. Ubuntu is like one of the go-tos for in terms of a Linux distribution. It's free like many of the other ones, but it's just fantastic. You might also notice down at the bottom here that it says it's going to be $32 a month. That is not the case. While DigitalOcean is a paid service, because honestly, the free ones I found out there aren't going to be good for what we want to do. I did try some of them, but it is a paid service. $32 a month is not what we're paying though. So $32 a month is if we wanted to be able to use an NVMe SSD with a premium Intel processor. That's like 4 gigs of RAM, 2 Intel CPUs, 120 gigabytes, 4 terabytes of transfer. We don't need that, okay? We don't need that at all. Instead, we're going to spend $4 a month. So in order to do that, we're going to go ahead and click regular and go over 1 to pay $4. So that's 0.6 cents per hour. So that's going to mean 512 gigs or megabytes of RAM, 10 gigabytes of SSD, and 500 gigabytes of transfer. The nice thing about DigitalOcean is if you do want to increase the capacity for any of these things at a later time, you can do that. So if you feel like that's maybe not going to be enough later, totally fine. Just do it later. All right, so now we're going to scroll down and go to the authentication method. So here, for me, I have some SSH keys already defined with my DigitalOcean account. If you don't want to use SSH keys, that's totally fine. You can just click create password or the password option on the right and select a password or type in a password for your root user. I would recommend SSH keys in the long term because they're super useful. It means you don't have to type in a password. Your server would just know that your computer is trusted to be able to access it. Fantastic. It's so nice. I don't have to remember the passwords for stuff really, so I like it. So I'm going to go ahead and click or fail to click and then click select all again. And then we're going to go down here. So one thing you can do is give yourself a host name on the right here. Just this, give your droplet an identifying name. I didn't do that here. It doesn't really matter that much though. And then you can just go ahead and click create droplet. This video, by the way, I would highly recommend that you follow along if you intend to try to do this as well. I know it might cost you $1 maybe. But if you want to be able to host your own server, following along is going to be the easiest way to kind of get set up. All right, so we can see our server is ready to go and we have an IP address. I am now going to open up the command prompt. And within the command prompt, we're going to do SSH root at the IP address that we just created, or for the server we just created. Now, SSH is a protocol to allow us to basically access the command line on another server. So root means we're specifying the user as root, and then at is the root at which address, basically is what we're doing. So the first thing we're going to do once we have logged on to our server is we are going to create a new user. Because when you create a new server, you want to make sure that, that all of the stuff that you do for that server is not attributed to the root user. So you're just going to follow along with the prompts. You're going to do add user. In this case, our user is called Flask host. Again, the reason you want to make sure that things aren't attributed to your root user is mainly a permissions issue. If a user gets access to your root account, then they have access to everything in your server, including users who aren't the root. But if they get access to my Flask host user, then maybe they only have access to, well, the Flask stuff, but they don't have access to the rest. Maybe I have other stuff on there. So if you want to host like multiple things on your server, then it's a good idea to have multiple users for each thing that you're doing. So the next thing we're going to do is allow our user to use the sudo command. And we're going to do that by doing usermod -a capital G sudo and then Flask host. So I know that might be counterintuitive to what I was just talking about, but it at least has some layer of connection. Separation, not connection. All right, the next thing we're going to do is set up a firewall. In order to do this, we're going to do UFW space app space list. And this is going to list the available connections for our firewall. We're then going to do, I'm going to zoom in a bit here. We're then going to do UFW. I'm going to fail to type UFW because I can't spell, apparently. Things are going great. Should be UFW allow open SSH. I correct that just here because I'm like, what is going on? Because I just can't spell. So that's what's going on. So we're going to go ahead and do UFW allow open SSH, which is right here. And then that updates the rules to allow open SSH. Then UFW enable, which will enable the system firewall. And then if we do UFW status, we can see that the open SSH firewall has been enabled and we are active. It's always good to have a firewall to limit access to stuff if we want to. All right, here it's actually a little bit interesting. So here I'm actually, I forgot to do something, but I tried to exit and log in as our Flask host user, but I wasn't actually able to do that. And the reason for that is because that user doesn't have permission to use the SSH key that my root user has access to use. So in order to provide the root user SSH key permissions to my Flask host user, I need to type out rsync --archive --chown equals Flask host /Flask host, and then this squiggle //.ssh/home Flask host. Just copy this whole thing. Not a big deal. But when this happens, it then means that I can then go ahead and exit and I can successfully connect using my SSH key, again, no password, to be able to connect using my Flask host user. So we can see we've done that, and we can even see that it is now green rather than just white. So yeah, green. So the first thing we're going to do is we're going to actually eventually install Nginx, which is basically a way to, like you can kind of think of like a simple web server, but it allows you to kind of define which connections you want to come into your server. We're then going to install something else called Gunicorn, which is like a unicorn with a gun, I guess, which is a reverse proxy, which is going to allow us to host multiple versions of our server, or basically multiple threads of our server, so little workers, so that more than one person can connect to our server at a time. So to start out, we're going to do sudo apt update, and this is making sure that our whole server is updated. And here we're going to provide the password for the Flask host user that we just had created before. Once that is done, we're going to do sudo apt install Nginx, and this is again going to be our web server. We're not going to do all the, we're kind of going to go through like the installations, and then we're going to set up some of the stuff. So we have done the install for Nginx. Then we're going to do UFW app list. Now we can see here when we do this, we have more options than OpenSSH. So we're going to now actually allow HTTP for Nginx. Rules have been added. Everything is good to go. When we do status, we can see that the HTTP for v4, I think, and v6 have been allowed. And if we do systemctl status Nginx, we can see that the Nginx process or service, is active and is running. Now, systemctl is like the system control for Linux, at least for Ubuntu. Some things differ between some distributions, but for Ubuntu, systemctl. And then you can do status, you can do restart, you can do start, you can do stop, the general things you might imagine, to be able to basically control these services that are running on your server. So here we're just verifying that the Nginx service has started. And we can see that it's live and it's happy. All right, the next thing we're going to do is we're going to actually set up Flask. So we're going to do a bunch of things here, but the first thing is sudo apt install python 3-pip, python 3-dev, build-essential, libssl-dev, libffi-dev, and python 3-setup tools. When we do this, it's going to say, do you want to install 302 megabytes of stuff? Because that's what we need. And we're going to say yes. Great. Then we're going to do sudo apt install python 3-venv. This is going to install a or allow us to use virtual environments for Python. If you don't know what virtual environments are, I'd recommend you check out this video right up here, because it is how you should be setting up dependencies like Flask or whatnot within your projects. I typically don't use it on my channel, which I know is probably bad, not a good setting a good precedent, but it is something that you should be doing. So we're going to do that here. We're going to do it right on our server. All right, so once we've done that, we are then going to create a directory under our home. So if you ever see a little squiggle, the tilde, and then /, that means the home. So that's the same as typing /home/ whatever the user is, in this case, Flask host. And we're going to be making a directory called Flask app. So that's where we're going to put all of our Flask app stuff. So we're going to make the directory, and then we're going to do cd change directory into that directory. And then ls, just listing the stuff that's there. Then we're going to do python 3-m-venv, and then we're going to name it Flask proj, proj. And when we press enter, it's going to look like nothing's happened, but it's actually going to create a new folder, and we're going to do source Flask project or proj/bin/activate, and that is then going to allow us to activate the Flask project virtual environment for this directory. This then means that we can just do pip install, and it knows which pip we're talking about because it's within this environment. And we're going to install wheel. Wheel is just like an overall thing that a lot of it's like a library, I guess, or a set of libraries that a lot of things use. So if we can just do install wheel, we're going to make sure that that's not really going to be an issue for other stuff. Great. We are then going to install both Gunicorn and Flask. All right, the next thing we're going to do is do nano Flask app. So again, basically I don't know why I did the thing there. We can just do nano app.py to create an app.py file. And then we're going to paste this code in here. So all we're doing here is doing from Flask, import Flask, app equals Flask name, and then define a simple route where we're just going to have a blue header saying hello there. And then if the name is main, we're going to run our app on the host of 0.0.0.0. Now, this is important, specifically that part, because we're going to need to reference that later on. So when we do eventually update our own code so that it's running, which we will do at the end of the video, we're going to make sure we update that. Now, because you're using nano, if you want to actually exit the file, you're going to do Control X and then Y and then enter. That's just how it works. You can't click stuff because you're in a command prompt. That's how nano works. If you want to use Vim, that's totally fine too. I just find when you paste stuff into Vim, it doesn't really maintain formatting very well. So that's why we're using nano. All right, then we just cat the app.py, which is just kind of printing it out. Then we're going to do sudo ufw allow 5000. So that's going to basically allow port 5000 to be accessible on our server. So it's opening up port 5000 on our firewall. Now, why are we doing that? because if we just do python app.py to run our Python server, we should be able to go to our server's IP address on port 5000, and we should be able to see, well, our hello there, our big blue hello there. Paste in that IP and 5000, and we can see hello there. So we know for sure that we are able to hit our server, go within port 5000, and go to our singly running simple Python Flask server. So far, so good. But we have a little ways to go for it to be a little bit more useful. All right, so now we're going to kill our server and do nano wsgi.py. Now, wsgi.py is just going to basically be a wrapper for our little Gunicorn server. Now, within here, we're going to put some really simple stuff in, which is going to be from my project, which you're going to rename to be whatever your file is. So in this case, I believe it's just called like Flask project or Flask, or I called it app, but it should be Flask app. So for our WSGI file, we want to make sure it says from, then whatever our app is called. So ours is now called Flask app, and we're going to import the app, which is just like the Flask app instance. And then we're going to run it if it is the name main. Then we are going to, before I had it called app.py, but I renamed it to flaskapp.py using the move command within Linux. Then we're going to do Gunicorn space -- bind 0.0.0.0. Remember I was talking about that? Colon 5000 and then WSGI : app. So what is this doing? So it's basically creating a Gunicorn server that is binding the 5000 port. So it's kind of routing it through Gunicorn into our Python instance. So that means that if we go ahead and actually try and see this again within our web server or within the internet, we can see that it works. But this time it's going through Gunicorn. So before it was going just directly into Python, and now it's going through Gunicorn, then into our app because it's bound through Gunicorn. Heck yeah. So now we're going to define a Flask app service. So we're going to do sudo nano /etc systemd system flask app.service. Now this service is specifically going to be the Gunicorn service. So within here, I'm just going to go forward to actually show you all of the code here. All right, so this Flask app service is going to look exactly like this. You might want to change things if you didn't call your user Flask host, for instance, or if your directory is not Flask app, or your virtual environment is not called Flask project. But this is what you're going to want to do. So let's go over it a little bit. So we're defining the unit itself, so the service itself. It's going to be called the Gunicorn instance to serve Flask app. It runs after the network's target, which means I believe this means that it runs after Nginx. Maybe I could be wrong about that. But so anyways, put that in there. Some of these you just kind of have to be like, yeah, just do it. The service that we're defining is being run by Flask host. So if you didn't name your user Flask host, then change that. Group is www-data, which is important because that is the group, which in Linux terms means it's kind of like you can have like a Google group or something like that, where it's a group of users all together. And in this case, www-data is a group that is typically used to serve website information or data, or just to serve websites. Working directory, we're just setting it to our Flask app that's within our Flask host's home. The environment, we're adding our Flask project's bin to the path. The reason we want to do this is so that when we run it, we can do home Flask host, Flask app, which is this exec start, Flask project bin Gunicorn. So Gunicorn is now added to our Flask project's bin, and we are specifying that we want 3 workers for this. So this will mean that we'll have 3 different threads of our server running, which is awesome because then multiple people can use our server at the same time, even if one thread is taking a long time. We're then binding Unix to the Flask app sock. Now this is like a socket connection that will allow us to basically route our traffic from our Nginx server to this Flask app sock. That's what's happening. So you'll see that soon. Then we're doing -m007. To be honest, I don't know what that one is. And then this WSGI:app, which is exactly how we did it before. Then we want this by this multi-user target, and we'll keep going. Then we're going to do sudo systemctl, again, our system control, and we're going to start our Flask app service that we just defined. You don't have to add the service. You can just do start Flask app. Then we're going to enable the service. Even though we've started it, we're going to enable it. And when we do that, it creates this symlink. So that means that this multi-user target once symlink has been created. Then we're going to just check the status of this service, because sometimes when you start a service, it won't give you an error, but then when you go ahead and actually try and use it, it doesn't work because it had some kind of issue. So we're going to do sudo systemctl status Flask app, and we can see right here that everything's working. And we can also see that it's actually working. There are different workers on different PIDs here. So we have the root PID, which is the initial version on 4613, and then we have different ones on 4614, 15, and 16. Those are the actual ones that will receive the traffic. All right, next we're going to create our Nginx site config. So in order to do that, we're going to do sudo nano etc nginx sites available Flask app. Now, when we get to the config for this, it's pretty simple. It's just server, and then listen on port 80, and then we provide our server name, which is just going to be our IP address, and then we do a www.IP address here again, which to be honest, you don't need that really here. It's just saying like what are the available names when accessing our server that we're going to allow to be mapped to this service or this server. In this instance, if you do have something like a URL, like google.com or whatever, you would put that here as well. Then we're going to define our location, which is like our root. So the slash is just the root of the root. And then we're going to include proxy parameters. So if you include something within that request, it's going to get proxied along as well. And then we're defining the HTTP protocol to pass it through for Unix. And then we're passing it to our Flask host, Flask app. Specifically the Flask app's sock. Again, which is kind of what we defined within our Gunicorn server. So we're going to go ahead and save this. And then we're going to link it. So this is a little bit of a unique thing to, as far as I know, within Linux. I mean, you can do it in Macs, I guess, too, because they're Linux based. But we're going to create a symlink from that Flask app configuration within sites available into sites enabled. So this will mean that if we go to the /etc nginx sites enabled, there will actually be a Flask app file there. But when we go to that file, it's actually going to the one that's within sites available. The reason you do this is that if you update a configuration within sites available, you don't have to maintain two copies. You're just kind of like creating the one copy, and then just in sites enabled, you're just pointing to the other one. So this means, though, that when we restart our Nginx server, or when we start our Nginx server, we will be able to see that a Flask app, has been included in the sites that are enabled. So we do sudo nginx-t, and this just verifies that the configuration is fine. So we're going to do the sudo systemctl restart nginx, and that is just to make sure that the Nginx service has been restarted with our new site that has been enabled. And then we're going to do sudo ufw for our firewall, and we're going to delete the allow 5000 rule. The reason we wanted to delete that is because we don't want people to be able to access our server on port 5000. We only want them to be able to hit us on port 80, which is how the internet typically is used. For websites, at least. All right, then we're going to do sudo ufw allow nginx full. So we're allowing all of the nginx functionality. And then we're going to go ahead and see if we can access our website. So if we get rid of our port here and we get a 502 bad gateway. Uh-oh, what's going on? So the reason this is happening is because we never actually gave access to the Gunicorn server to the correct user. The permissions are a little messed up, which is totally fine. because we see right here, I was like, what's going on? Why is this happening? So I was restarting the Flask app service, and that wasn't the issue. The issue is that we need to do a sudo chmod 755 of home slash Flask host. So for our user, we want to make sure that anybody can basically access this directory. Not anybody, but 755 is like, there's like read, write, and execute access. And this is giving the read and write access, I believe. So now we can see that if we refresh the page with no port, we actually can access our hello there, which is awesome. But it's also not the site we've been working on up until now. So now that the server's working, we really can just update it a little bit and it should just continue to work, but it's going to be, the new version of the server. So we're going to do that right now. All right. So what we're actually going to do is we are going to get our code onto the server. Now, there's a few different ways to do this. The first way that we're going to use here is the scp command. It's like a server copy command. So normal copy within Linux or within the command line allows you to copy a file from one point to another point, but it's all on the same computer. The scp command allows you to copy a file onto a different computer just through the internet. Pretty awesome. Another thing we could do is use the FTP protocol, which is on port 22. You could get something like FileZilla and then connect to your server and then drag and drop files, totally possible. Or you could use something like GitHub, which if you intended to use the server long term, I would highly recommend because then it's super easy to just pull down new data and whatnot. But we're just going to use SCP. So the first thing we're going to need to do is we zipped up our video 8 file. So we can see that we have that right here, video 8 zip, 34 kilobytes, nice and small. And then we're going to do the scp command. So we're going to do scp video8.zip Flask host at the IP address for our server, and then colon, and then the directory we want to save it to. So home Flask host server.zip. So when we press enter, we can see that it went ahead and did that. We can see that it's 100% complete. And then all we have to do is just log back into or SSH back into our server. And we can see when we do ls, we have server.zip. Awesome. We're then going to move server.zip to our Flask app directory. And within Flask app, we are then going to unzip server.zip. If you don't have unzip, you can do sudo apt-get space install unzip. It's just not installed by default sometimes. So when we do that, we can see we have video 8 as a new folder. So it did successfully unzip it, but it's not in the right spot yet. So we need to get everything from video 8 into Flask app. So in order to do that, we're going to do move video 8 /* space period. So it's going to move everything from the video 8 folder into the current directory, which is dot. And then we get an error here saying cannot overwrite cache directory not empty. That's totally fine because when we do ls, we can see that it moved everything else. So we now have the templates, we now have static, we now have index style, which we're going to delete in a second. And then we have app. So app.py is actually all of the other stuff. So one thing we then need to do is actually update our WSGI file to point to the app.py. But again, we don't want it to be called app.py, so we're going to rename it to the app.py. So we're going to do mv app.py, the app.py, and that's going to rename it because now it's called the app instead of just app. Then within our WSGI, we're going to make sure that it says from the app import app. Awesome. So now if we're going to go in because we didn't actually have the 0.0.0.0 configured within our file here. So we're going to go here and we're going to go down to the bottom. Excuse the beeping. And we're going to change this from debug equals true to host equals the string of 0.0.0.0. Then we'll go ahead and save that. And then we are almost done. But the one thing we still don't have is we haven't actually yet installed all of the things that we need for our Flask app. So I'm going to copy the requirements.txt that I have from video from a different folder. I don't know if all of these are actually required, but we just included them anyways. And then I'm going to create a requirements.txt here. And we're going to paste them in and save the file. Then we need to basically activate our Flask project. And then we're going to install everything from the requirements.txt. But in order to do that, we need to activate our virtual environment. So we'll do source flask proj bin activate, and then we'll do pip install -r requirements.txt. And we can see I already have everything installed, but it would install stuff. And there we go. We're kind of good to go. So now it's the moment of truth. So just to be safe here, we're going to do sudo systemctl restart Flask app. And if we restart the Flask app here, I got to paste in my password again or put my password in again for the user. And we're going to check the status of it. We see that it's running. We see that we do have some PIDs running. Then we can see if we go to the server, we can go ahead and actually see that everything is working. The whole server is working. We can register, log in. We actually didn't even delete the user's DB. So the user, I try and register here, but the user already exists. So we can see that it is connecting to the DB fine. And I believe the dashboard still works. So we can go to the dashboard, add some data, test stuff, add data. And then I think I had to refresh in order for it to be there again. But yeah, pretty awesome. It works. So that is all for this video. I know it was a little bit strange, but hopefully it all made sense. I hope this is one that you followed along with, because it's probably hard to follow if you aren't like doing what I'm doing while I'm doing it. I will also leave in the description down below some of the tutorials I've found online that help with doing this, because DigitalOcean actually provides a lot of these tutorials and they're super useful. So these will include like how to initially set up your server to kind of get it going, how to let Flask and Gunicorn run on your server, probably Gunicorn again, but I like Gunicorn. So yeah, that's all for making a website. If there's any other questions or anything like that you encounter as you're trying this, definitely leave a comment down below and I can see if I can help you, or you can join our Discord server. That would be cool too. But that is all for this one. I think in some of the next videos, we might be looking at some hardware stuff. Got to figure out what the camera is going to be like for that, but that's a future problem, I guess. So that is all for this one. Have a great day.